Hello and welcome to one of those rare occasions where I am going to do a finance question on this channel. We are looking at question 7 from IEB's November 2022 paper 1. Cool. A person is able to pay 14,500 Rand per month to pay off a loan. The bank offers the person an interest rate of 12% per annum compounded monthly. My goodness, these interest rates. Whew. Anyway. What is the maximum loan the person can get from the bank if it needs to be paid back over a period of 20 years? Round down to the nearest 100. Okay, so we're going to borrow some amount P. It is going to grow at 12% per annum compounded monthly for 20 years. So that's 12 months for 20 years, so 20 times 12, right? So that's going to be the value of the loan with all the interest that it would accrue, right? And supposing that we want to pay this 14,500, the amount that we can afford to pay. So I'm not going to always, okay, maybe I should always. I was saying I'm not going to always draw this timeline and do my geometric series stuff from scratch, but yeah, I should because I'm forgetting how it works. So at T0 is where the loan would be granted, and then you typically then start paying at T1, blah, 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 blah. And at T240 is where you would make your last payment. So 240 months, 240 payments, right? So for each of those months, we're paying 14,500, 14,500, blah, blah, until over here. And it's almost like these payments also accrue interest in a way. So if I start with the last one, because the sum works out nicely that way, the last 14,500 is the one that closes the loan, so it doesn't earn any interest. But the one a month before that would earn interest for a month. Okay, and the one a month before that would earn interest for 2 months. Right, and so on until the very first payment, which would earn interest for 239 months. Right, and it's 239 because it didn't earn interest here, right? It only showed up over here. So at T2, it's earned interest for 1 month. At T3, it's earned interest for 2 months. So at T240, it will have earned interest for 239 months, right? So that gives us a geometric series, right? So we want this series, okay, this series, to add up to this, whatever the loan and its interest would accrue to. So the series is, okay, let me just write down the formula so that we can see what we are replacing with what. Okay, so the first term in my series is 14,500. The R, okay, each term is being multiplied by 1 plus 0,12 over 12, right? So you see that each term, this one, the change is this guy, and then this term and this term, the difference is that we've multiplied by another factor of this. Okay, right, the N, as in the number of terms in the series, there are 240 payments that form this series, and then again the R over here is 1 plus 0,12 over 12. Okay, right, time to move things a little bit. Okay, right, so yeah, we then want to figure out P, so we can divide all of this by this number over here, and that will give us P. I'm just going to work out what each of these numbers is so that, for the sake of writing things nicely. Okay, so that to the power of 240. So that is p times 10, 89, blah, blah, blah. And then let's work out the right-hand side. Oh, calculator. Ay, ay, ay. Okay, why am I scolding the calculator? I should be scolding my fingers. Okay, right. Sometimes it is so tricky getting this cursor where I want it to be. Okay, so that is 14,344. Oh, yo, and I lost my previous number. Oh, golly golly. Okay, so let's just store this while we're at it. Okay, so I've stored it inside A. Okay, and then my other number. Oh, I didn't lose it. So now what did I store in A? Oh, guys, okay. Right, so, oh, it's gone. Oops. Right. To bygones be bygones. We just store that in B for good measure. Okay, so now we want to say P is equal to 14,344, 202,79, blah blah blah, divided by the 10,89, blah blah blah. Okay, so that's going to be that number divided by this number, and that gives us, we were told to round down to the nearest 100, so 13168. Okay, so if we round it up, it would be 1316900, but because we're rounding down, it will be 1316800 would be, yeah, the amount that they can get if that is what they want to pay. Let's see. Yes, oh yes, wonderful, wonderful. Okay, right. And for those who use the present value formula, that was an easy two-liner question. Anyway, we're not there. Part B says, if the loan above is taken up by the person, what will the outstanding balance be at the end of the 8th year, immediately after the installment has been made, if they made payments of 14.5 per month? Okay, so the outstanding balance is going to be the difference between the loan and however much interest it's accrued at that point, and the repayments and however much interest they've accrued at that point. So that's what we're going to work out. So the loan, the value of the loan at that point would be, what's the number? 1316. Guys, why am I stretching my poor brain cells? Well, I mean, yeah, it's like sometimes I am in the mood to just do unnecessary mental labor, and other times I am not. Right, so after 8 years, okay, Okay, and then the repayments. Okay, so in this situation it will have been 8 years, so that's 96 repayments. The last one has not earned any interest, right? Because we're talking about immediately after that payment has been made. The one before that has earned interest for 1 month. The one before that has earned interest for 2 months. Okay, and so it goes and so it goes until we get the very first payment that has earned interest for 95 months. Okay, so again, our beloved geometric formula, geometric series formula, first term being that, the r being 1 plus 0, 1, 2 over 12, the n being how many terms, so 96 of them, and then the r again down here. Okay, yeah, I can definitely afford to shrink that. So we have that. Right, so the value of the repayment at that point is this, right? And I'm going to store that in B. Okay, so then the outstanding balance will be that first value minus the second value. Yeah. And the memo agrees. Awesome potatoes.